Hi, everyone. I'm Lucas. I'm here with Attentio. The whole Attentio team is here. They're scattered around, and I can't see them with the lights, but it's Julian, Jake, Dan, and Matt. And we're really excited to show off our language model training platform for the first time today. So language model, when I say that, I'm talking about the ChatGPT type models. So next token predictors, what we've done is we've created a new way to train language models that can update the knowledge base of a pre-existing model with a very small data set. So if you're familiar with ChatGPT's knowledge cutoff, you're chatting with ChatGPT, you ask it a question and it's like, oh, sorry, my knowledge base only goes up to October of 2023. That's the current model. And so like even OpenAI, who has huge supercomputers and a lot of money and resources to do training, they can only get knowledge base updates out once every 6 months or so. So that's the problem we're tackling. And we have a really cool, we think, elegant way of solving this problem, where we basically use prompt engineering and then optimize the model weights to preserve, that behavior when you had something in your context window. So I'll jump right in and kind of show how it works. So I have a chat interface here. It works the same way as ChatGPT, so I can just ask it a question. Who trained you? And it's going to give me a response back, and it's going to basically say it doesn't know. It doesn't give me an answer. So what this training method allows us to do is I can clear out the context window. I can tell it something I want it to know. So in this case, you are a language model trained by the company Attentio. And so I put that in the context window, and now I can use that as my loss function. I can optimize it to maintain that knowledge. So I'm going to go ahead and run the training method. And so as this is running, we are changing every single one of the 7 billion parameters in Mistral. And we do it in about 15 seconds, which is kind of unheard of for optimizing a model of this size. So I'm going to clear the context window now. So short-term memory is cleared. It doesn't have any information. And I can ask it, who are you? And it gives me a natural language response back. It's not the same sentence I trained on. It's grammatically correct. It answers the question. And it gets the name right. It remembers Attentio. The second really cool thing we can do with this is we can run it multiple times. So I can clear the context window, I can clear it again, and I can tell it something else I want it to know. So let's say you are based in Minneapolis. And it responds, confirms, so that's not new. That's just how language models respond. But now I'm going to transfer this into the model weights, so kind of like the long-term memory. It's going to run again. Takes about 15 seconds again. So every time we can transfer concepts in about 15 seconds. It used to be 3 minutes, and we've gotten it down over time. So I'll clear it again, and I'll say, who are you? So this is a cool response because it's used both facts that I embedded, and I embedded them separately. So that's not strange for prompt engineering, but it is strange for a technique that optimizes model weights. And as far as we know, this hasn't really been demonstrated before, where we can optimize the model weights at different times, and it can kind of seamlessly incorporate two pieces of information together. So I can even say, like, write a story about yourself. And it writes a story about Minneapolis, which definitely was not in the training set. Like, the training set was that message I sent it, so it's generalized very well. I'll show one more thing. So we can do other things besides facts. We can do behaviors. So I can say something like, please talk like a pirate going forward. And so that's in the context window. It responds piratey, but now I'll make it permanent. So this will be a permanent model. It'll always talk like a pirate, and it'll never go back to normal, So again, 15 seconds of training, and then we'll see if it worked. And I'll ask it to write a story or something. So context window is cleared. If I just say hello. Okay, that one. It's So sometimes you do, if you optimize a little too fast, so we can turn down the learning rate. I have it cranked up a bit here, and you can get these repetitions. But so let's see if we can write a story. Yeah, so we get a pirate story. Okay. So not the greatest pirate model in the world, but for 15 seconds of training, it's not too bad. Yeah, so that's the Attentio training platform. We can optimize models very quickly with very small data sets, and it's so all of that is running on an RTX 4090, which is like a consumer-grade GPU. So we don't have any crazy computing power to run this. It's all the optimizations we've done. We've done a lot of analysis on transformers, and we have a pretty good understanding of the inner workings of the attention mechanism, and that's allowed us to develop this method to optimize the weights and do it with less data and faster than other methods. And so finally, we are about to start providing access to this training method. So you can join the waitlist. We have a limited amount of compute, so it'll be kind of on a first come, first serve basis. But yeah, if you want to be one of the first people to try training a language model in this really conversational way, yeah, join our waitlist. And we also have a Hugging Face page. So if you have a gaming PC at home and you want to run your own language models, we have a bunch of language models that we've trained using this method. One in particular I'll draw attention to is called Golden Gate. It's a model that talks like the Golden Gate Bridge, and it works Golden Gate Bridge references into all of its responses. We stole the idea from Anthropic, but ours only takes 8 seconds to train. So that's a fun model. So yeah, that's the Attentio training platform. Thank you guys so much.